Initiating diagnostic scan on the gear assembly.
Copy that. Aligning the arm for laser calibration. Sensors are green. Proceed with the surface scan.
Scan complete. Data looks optimal.
Confirmed. The power coupling looks stable in the sim. Yes, but watch the heat signature under load.
Increasing thrust. The vector is stable.
Good. Let's check the auxiliary systems. Rerouting power now. Initiating full surface scan. Copy. Monitoring data flow. Pattern match confirmed. Anomaly scan initiated. Confirmed. Panel integrity is good. Extracting the module now. Diagnostics are clear. You are good to proceed. Arm. The F-35 Lightning II begins its journey here, in high-tech design labs, where engineers create precise 3D models and futuristic plans for this next-generation fighter. Let's analyze the engine integration. Systems are stable. The fuselage stress points here need to be reinforced.
I agree. Let's adjust the material density.
We should also check the wing attachment simulations. Good point. I'll pull up the latest data and verify.
Looks solid. Let's proceed.
The simulation confirms the stress point here. I see. We can reinforce this joint. Right. A slight redesign should fix it. Let's get a closer look at the lattice. Agreed. That will improve durability. Let's start with the HUD placement for optimal visibility. Agreed. We can mirror it on the right MFD.
Good. That keeps the throttle quadrant clear.
Perfect. This balances comfort and tech. Readings look stable, confirming vacuum integrity. Confirmed. Pressure is at 10 to the minus 9. Good. Check the calibration on the sensors. Sensors are aligned, no anomalies. Excellent. Logging it. Blueprints are meticulously analyzed, each structural component scrutinized for maximum performance and stealth capabilities. Raw materials like titanium and carbon fiber form the backbone of the F-35, chosen for strength and lightweight performance. All right, locking in the primary harness now. Copy that, checking the schematic. Voltages look stable, moving to secondary. Confirmed, secondary is green, good to proceed. CNC machines carve precision titanium panels, shaping the fuselage with meticulous care. Steady on the feed rate. Adjusting now. Looks better. How's the tolerance? Within spec. Keep it steady. Confirmed. Good. Initiating sequence. All systems green. Copy that. Monitoring structural integrity. Welding phase complete. Moving to alignment. Alignment confirmed. Ready for next phase. Check the alignment on the turbine blades. Alignment is good, passing the calibration tool. Fuel lines secure, ready for the next phase. Electricals are stable, proceed with assembly. Confirmed, locking it in. The team works diligently on several small engines, each on its own cart, combining precision and teamwork to prepare the F-35's components for assembly. Ready for next phase.
Initiating diagnostic scan on the gear assembly.
Copy that, aligning the arm for laser calibration. Sensors are green, proceed with the surface scan.
Scan complete, data looks optimal.
Confirmed. Check the navigation interface. Any anomalies? Signal's intermittent. Could be a connection issue. I'll tighten the primary bus connector. Good. Recalibrating now. How's the signal now? Stable. We're good. Alignment looks good. Proceed with securing the connectors. Connectors locked. Moving to the panel now. Panel is clear. Ready to close. Confirmed. Closing now. Looks secure. Good work. This panel alignment is off by a few microns. Check the data here. It's reading a variance. Okay, adjusting now. Good. Torque it to spec. Confirming. We're good. Panel's open. Running the continuity test now. Check the junction box. The schematic shows a possible short. Copy that. I'm seeing the same error on my screen. Okay, probing the connection now. Alignment checks out. Proceed with harness install. Copy that. Bench tests are green. Harness locked in. Running final continuity. All systems nominal. Initiating torque simulation.
Rotational velocity is optimized.
Material stress test passed. Perfect. Locking in the design.
Confirmed. Sync complete. Let's isolate the parietal region and run the simulation.
Agreed. The neural pathways are stabilizing now.
Good. Now, let's check the frontal lobe activity.
The activity is spiking. This is the breakthrough we needed. The power coupling looks stable in the sim. Yes, but watch the heat signature under load.
Increasing thrust. The vector is stable.
Good. Let's check the auxiliary systems. Rerouting power now. The pressure distribution here is optimal.
But the thermal model shows a hotspot.
Let's run the simulation with the new parameters. Uploading them now. Watch the display.
The efficiency is up 3%.
Perfect. The simulation is stable. Let's test the load distribution. Agreed. Check the shear points on the fuselage joint. Initiating the sequence. Watch for anomalies. Looks good. The integrity holds at 150%. Voltage is spiking. I'm rerouting power. Copy. Checking the main bus. It's fluctuating. I see it. Bypassing the faulty relay now. Good. Monitor the core temp. It's climbing. It's stabilizing. We're clear. Connection is secure. Powering up. Roger. Checking harness tension. Diagnostics are green. Proceed. Manual override engaged. Testing ejection sequence. Looks good. Let's run the full sim. Agreed. Good work. Initiating full surface scan. Copy. Monitoring data flow. Pattern match confirmed. Anomaly scan initiated. Confirmed. No deviations. Log the metrics. Logging complete. Scan finalizing. Initiating the scan. Watch for irregularities. Laser is sweeping. Data looks clean. Confirmed. No anomalies. Good. Prepare for the next phase.
Initiating laser calibration.
Readings are stable. Proceed to scan. Alignment is perfect. No anomalies.
Excellent work, team. Calibration successful.
Left arm engaging. Fuselage alignment is green. Copy. Holographics confirmed. Structural integrity is at 98%. Initiating canopy scan. Systems are optimal. Check the schematic. This bundle looks off. Voltages are fluctuating. I'll scan it. Readings are unstable. Possible short. Okay, tag it for replacement. Noted. I'll log it.
The vector field is unstable. I'm recompiling now.
Copy that. Checking the render log. There's a spike in the metrics. Look here.
I see it. Isolating the module.
Good. Run a simulation. Running it. Eagle 1, vector to target. Confirm systems check. Eagle 1 copy. Systems green. Engaging. Target acquired. Clear to engage. Weapons hot. Strike confirmed. Good effect. RTB. Panel integrity is good. Extracting the module now. Diagnostics are clear. You are good to proceed. Arm aligning to the wing strut now. Check the avionics data on this. Signal's weak. Scanning the bus. Try the secondary port. Rerouting. Testing continuity. Readings are nominal now. Good. Log it and seal the panel. Alignment is spot on. Initiating phase 2. Confirmed. Structural integrity is green. Okay. Proceed with the robotic arm. Arm is active. Monitoring.
Alignment looks good. Check the panel seal.
Confirmed. Running the sensor diagnostic. Torque is set. Locking it down.
Good. Let's move to the avionics bay.
Copy that. Ready when you are. Status on the nose gear. All clear. No leaks. Canopy seals are good. Avionics check complete. Hand me the torque wrench. Pressure readings are nominal on all three jets. Confirmed. Avionics are syncing perfectly. Good. Note the wing alignment for the lead jet. Let's get a visual on the fuselage. On it. Pulling up the diagnostic feed. Looks good. Initiating descent. All stations confirmed. Copy. Wheels are prepped and ready. Background systems green. Proceed. Descent confirmed. Deploying gear. Alignment good. Securing wheels now. Lock engaged. Jet is grounded. Check the avionics on the nose cone. Readings are stable. Running the alignment. Tail section hydraulics are good. Confirmed. Moving to mid-fuselage. Good work. All systems green.